What is up, you guys? It's Max here, and in this video we're going to solve Hamming distance in Python. So the problem description reads that the Hamming distance between two integers is the number of positions at which the corresponding bits are different. So if we're given two integers in this example, 1 and 4, the output is 2, because if we look at the binary representation of the number 1 and the binary representation of the number 4, we could see that the bits are different at the 2 to the 2's place and the 2 to the 0 place. And so that would be 2 places that are different, so the output would be 2. I'm going to kind of break this video into like 3 parts. First, we're going to go over bitwise operators and how we can use them in our solution. I'm going to kind of illustrate how our code would work in MS Paint and then jump into VS Code and show how we can get our answer. So before we even start this, it's important to know a couple bitwise operators. So the ones we're going to be using in this video are the exclusive OR. So when we take the exclusive OR of two integers, it basically will output, if we're comparing two integers and their binary representations, it'll flip the bits to 1 where they're different and just stay 0 where they are not different. They'll do put a 0 where it's not different. So I'll give you an example. MS Paint. So if we have the integer 6 and the integer 1, and we take the exclusive OR of these two, so here's 6, we have 2 to the 0's place, 2 to the 1's, 2 to the 2's, we have 4 plus 2, we have 2 and 4, so that'd be 6, and we have 1. If we take the exclusive OR of those, it would actually be 1, 1, 1, 1. 1, 1, 1, excuse me, because they are different in every single place. So that would be 7. The exclusive OR of 6 and 1 would be 7 in binary. Now we have to think and take into account, how would this help us? Well, if we count all the 1's in the string, it actually is the Hamming distance. We count the 1's, so it would actually be 3. And you can, double check. We look at 6, we look at 1, they're different in 1, 2, 3 places. Now, if we take their example, let's just say, delete all this mumbo jumbo, and let's just give their example. I think it was like 4 and x equals 4, y equals, I think it was 1, right? And we look at the binary of 4, which is, we have 2 to the 1's, 2 to the 2, 2 to the 0, 2 to the 1, and 2 to the 2. And we have 1, which is 0, 0, 1. And we take the Hamming distance, it would be 2. Because we just, and actually, so if we take the exclusive OR, ready, watch this. So it would be, it's different here, it's the same here in the middle, and it's different here. So the exclusive OR of 4 and 1 would actually be 5. And if we count all the 1's in this representation, it would be, there would be 2 1's, which is exactly the Hamming distance. Now, the question is, after we take the exclusive OR, how do we get it? How do we count up all the 1's in this binary? Well, I have the answer. We can loop over that binary and keep shifting the bits to the right. Now, what does that mean? This operator will shift the bits to the right by shift the bits to the right. Oops, I just jumped into the VS Code. But let's say we were to shift this by 1 place. Let's think about this. If we were to shift it just 1 place, I'll give you an example. It'd be like almost like everything would get shifted over 1. So this one would get this one right here would get pushed out, and there'd be a 0 kind of appended at the beginning, and this one would get pushed to the middle. And now, how can we? And then if we were to keep pushing it, we were to keep shifting bits to the right, we get like something like this until we eventually shift all the 1's out. And so, as you can see, this sequentially will keep pushing things out until we've populated all the 1's out of our binary, and then the integer representation is 0. So it goes from 5 to 2 to 1 to 0. So yeah, I will do that, kind of show that. 5 to 2 to 1 to 0. And so we can do a while loop. So while so we'll get a result by taking the exclusive ORs of these two integers. And while that result is greater than 0, we are going to keep shifting the bits to the right. And then how do we extract how many ones there are? Well, we're in luck. I happen to have used our nice friend Google, and there is a bitwise AND operator. And so if we use this, and we can extract the lowest bit, and we can check if it's equal to 1. Now, why is that useful? Because we can keep checking, hey, is this one equal to 1? Yes, add to our count. We have a count variable, right? So in our first iteration, we say, hey, is the lowest bit equal to 1? Yes, increase the count. Boom, shift the bits. Okay, is this one equal to 1? Nope. All right, shift the bits again. Is this one equal to 1? Yep, equals 2. We shift here, but now the result is now it's equal to 0. So we would break out of our loop, and we would get the Hamming distance finally. Boom. All right, I'm going to show this now in code and how we could do this. I'm going to use the exact same example with 4 and 1 because we kind of went over it here. I'm going to show it in the debugger and how we could solve it. So I already have the debugger up, but let me do 4 and 1 here. We're going to save and refresh our debugger. All right. So we store the exclusive OR. Ready? 5 here. I'm gonna split screen this actually. Cha-cha. Cha-cha. All right. So we have we took the exclusive OR of these two integers, which is 5, right? So it gets stored in result. While result is greater than 0, we are gonna keep shifting the bits to the right. I'll print the result. Yep, 5. We check if the lowest bit is equal to 1, which in this case, yes, it is. We'll increment it. Then we shift over the bits by 1. So we take this integer, which is 5. We shift over the bits 1. And so next, the result should be 2. Boom. Yep, it's 2. All right, it's still greater than 0. Print it. 2. You see that in the console down here. And now, we don't add to count because you see it's extracting the lowest bit, and 0 is not equal to 1. So now we'll shift the bits over again. Result is now equal to 1 because we shifted the bits over. You can see on the right at the binary representation. We print, it's 1, and now our bit at the lowest possible value is equal to 1. So we would increase our count. We shift the bits again, and now it's all zeros. Result is 0. So we break out of the while loop, and we return count. And that should do it. So I'm going to take this and pop it into LeetCode and pray to the LeetCode gods that this works. So we're going to run it on their test case. Yes, we got it. We'll submit. And would you look at that? We did it. All right. That is the solution to Hamming distance. And I hope you enjoyed. Feel free to leave a like if you found this video helpful. And I hope to see you guys in the next video. All right. Peace.